So what do we use matrices for? We use them for a number of different things, but really what we use them for is to represent information. We want to present information in a matrix. It's a nice, neat way to store information or represent it. Information that you might get from network diagrams. So network diagrams can represent, connections between towns, handshakes, bridges, all of that. We'll get to that in a moment. So using a matrix to represent data tables. So represent the following contingency table for sports preference as a matrix. So you can see here I've got just, your normal table with your sports, AFL cricket, so very Australian based, and weather. So 26 men preferred AFL, 22 women preferred AFL, 15 men prefer cricket, 9 women prefer cricket, to get those totals there. Okay, we can also then present that information as a matrix. Notice that we've then sort of labelled the columns and the rows to make that a bit clearer. So the table here, this is another example we can work through, shows the number of customers walking through the doors of 2 businesses over the long weekend. So Saturday, Sunday, Monday. Organise the data into a matrix. Let the position of each element be the same as the position on the table. So how would we do this? Okay, so it's going to be a 2 by 3 matrix. Okay, and 150, 134, 130, 124, 133, 115. Might make that 0 a bit clearer. Yeah, that's better. Won't confuse it for a 6 now. Okay. The table shows the average temperature in degrees Celsius in 2 cities over the 4 seasons. So, here's our example. We've got Brisbane, which is in Queensland, and Tripoli in is that Italy? Is that Turkey? I'm not sure. Anyway, it's now being organised into a matrix. And you can see here that it's not exactly looking like this. Okay, so if we were to just write that out, just put basically the brackets around like that, we'd be expecting a 2 by 4. That's not what we got. We have a 4 by 2. Okay, so which one of these statements is true? The rows represents the values for each city and the columns represent the values for each season? Or do the rows represent the values for each season and the columns represent the values for each city? Well, looking at that, 31, 22, 17, 25. So that's looking like that column represents Brisbane, that column represents Tripoli. So that's B. Okay, now for our past exam questions. Those questions were from Mathspace I found a couple of years ago. Okay, so question 1 from exam 1 from 2019 Northern Hemisphere exam. Remember, question 1 means it's judged to be a straightforward question, no tricks here. The number of individual points scored by Rihanna, Susie, Tina, Ursula and Vicky in 5 basketball matches is shown in the matrix P below. Okay, so you can see we've got matrix P here. So we have, these are the games, these are the players. So this is Rihanna. In match F, she scored 2 points. In match G, she scored none. In match H, she scored 3. In match I, she scored 1. In match J, she scored H. That's how we can read that. So, who scored the highest number of points and in which match? Well, looking at that, 8 is the highest number of points, and that is Rihanna in match J. So E, and yes, that is correct. So you can see, oops, there's Susanna and her matches and points, Tina and Ursula and Vicky. Okay, so 2018, exam 1, question 3. So still relatively easy, but not as straightforward as question 1. So we've got 5 people, India, Jackson, Krishna, Leanne and Mustafa, competed in a table tennis tournament. Each competitor played each other competitor once only. Each match resulted in a winner and a loser. Okay, so they only played each other once, and somebody won, somebody lost, there's no draws. The matrix below shows the tournament results. A 1 in the matrix shows that the competitor named in that row defeated the competitor named in that column. For example, the 1 in the 4th row shows that Leanne defeated Jackson. Okay, so here are the winners, here are the losers. Okay, a 0 in the matrix shows that the competitor named in that row lost to the competitor in that column. Okay, there is an error in the matrix. There's a mistake somewhere. The winner of one of the matches has been incorrectly recorded as a 0. This match was between. Okay, so how are we going to tackle this? Well, let's go through and see if everything makes sense. By the way, here you can see that India, playing India, they've just put that as a 0 because then you can't play yourself, so you can't beat yourself, basically. So that's why that leading diagonal is 0. So it's saying that India defeated Jackson. Let's come down here, and yes, that matches up, doesn't it? Because that says that Jackson lost to India. India lost to Krishna. Let's come down here. Krishna, yep, defeated India. India won against Leanne. Leanne lost against India. Okay, India lost against Mustafa. Lost against Mustafa, so that should be a 1, shouldn't it? Because Mustafa defeated India, according to this. Okay, so I think that's where the mistake is. India, Mustafa. Now we can double check some of these. Now, perhaps seeing as we've got these options here, I could have just narrowed down on these options and just looked at India, Mustafa, India, Krishna. I've done those. Krishna and Leanne. Okay, Krishna and Leanne. Okay, that's saying Krishna defeated or beat Leanne. And that's saying Leanne lost to Krishna. Yep, that's right. Leanne and Mustafa. Leanne lost to Mustafa. Mustafa defeated Leanne. Yep. Jackson and Mustafa. So Jackson defeated Mustafa. And Mustafa lost to Jackson. So, yes. And double checking India and Krishna. India lost to Krishna and Krishna defeated India. Yes, so definitely A. And 78% of the state answered that one correctly. Okay, I might pause here and then we'll go on to part 2, network diagrams.